Hello there, Mr. Sutton bringing you another lesson on circles. In this one, we'll be graphing circles. So let's go through how to graph a circle, and then you can try one on your own. First step, find and plot the center. So for this one, that's going to be -2, 1, which will be right over here. Next, find the radius, and then use that to plot 4 dots that are the radius distance away in each direction from the center. So our radius in this one, square root of 9, that'll be 3. So we need to go 3 away in every direction. Now, when I say every direction, I'm just talking about up, down, left, and right. It's hard to judge how far 3 away is if we go diagonally, but in those 4 directions at least, we can figure it out. So we got 3 up, 3 to the right, 3 down, and 3 left. For the last step, you got it. Connect the dots. So there's our circle. Woo! And we're all done with this. Here's another circle example. Pause the video and see if you can graph this one on your own. All right, so for the center, we've got 1, 0. For the radius, we've got square root of 16, so 4. And let's just graph 1, 0. There we go. And then radius of 4. So we're going 4 up, 4 right, 4 down, 4 left, and connect the dots. There we are. Now that we know how to graph a circle, we're going to talk about graphing a semicircle, which can also be important. To do this, we first have to square this and rearrange to put in circle form. We're going to pretend it's a circle. It's really not, but we're going to make it look like a circle just to help ourselves out. So squaring both sides, I've got y squared equals just 25 minus quantity x plus 2 squared. Next, I'm going to add this x stuff over to the left side. And now I have what looks like a circle. Again, we know it really isn't, but we're going to graph it like it is for at least half of it. For our next step, we're going to use 3 dots to graph our semicircle based on the variable in the original equation and also the sign of the radical. So here's our operating kind of method for this. If you have x equals a positive square root, you have to graph the right half. X equals a negative radical is the left half. For y, we're going to graph the top or the bottom. Y equals a positive radical, we graph the top half. Y equals a negative radical, we graph the bottom half. So let's go through now, get our center, our radius, and then we'll figure out which part of this semicircle we're graphing. For the center, we've got -2, 0, which we'll put on our graph. For the radius, that's the square root of 25, which is 5. And now which half are we graphing? The original equation had y equals a negative radical. If you have y and negative, that means you're graphing the bottom. So we go 5 in every direction, and we graph the bottom half of the circle. So we'll go 5 to the left here, 5 down, 3, 4, 5, and 5 to the right. And that's just the semicircle we're going to graph there. Here's another semicircle example. Pause the video and graph this one on your own. All right, let's see how you did. So hopefully you started by squaring both sides. Actually, before we even do that, let's move the 4 over to the left side. All right, now that the square root is isolated, we can square both sides. So that's x minus 4 quantity squared equals 16 minus y plus 3 quantity squared. Add all that stuff with y over to the left side. There's our circle-esque kind of equation. And let's get some important stats out of this. Our center, we've got +4, -3. For the radius, square root of 16 is 4. And since our original equation had x equals a positive radical, we're going to have the right half. All right, let's graph it all out now. So we've got 4, -3. And the right half now, so we're going 4 up here, 4 to the right, and 4 down. There we are. This concludes our second lesson on circles. Until next time, this is Mr. Sutton signing off.